Okay, good morning. Today we are continuing with probability. We are doing CO71. I can use the counting principle to find the number of possible outcomes. So this will not work if they say, how many of the two evens will you get? You need to be able to do a tree diagram to find how many of your outcomes are even. You can use this to find out the possible number of outcomes. So this won't work for every probability, but it will work for a lot. So outcomes are that possible results when an experiment is performed. Event is the collection of outcomes of an experiment. So an event that involves tossing a coin to getting heads. So that event is how many times will that coin land on the side of heads. Probability is a number from 0 to 1 that measures the likelihood that the event will occur. Talked about that yesterday. It's always going to be between 0 and 1. It's never going to be bigger than 1 because you can't have more successful outcomes than the total number of outcomes that there are. So here's the key concept for our counting principle. If one event can occur in m ways, for each of these, a second event can occur in n ways. Then the number of ways that the two events can occur together is m times n. So what Will said with the dice problem in our homework, he said, well, you didn't really have to count them all up. You could just multiply 6 times 6 because there were 6 outcomes for the first event and 6 outcomes for the second event. So that would have been 6 times 6. So if you're just looking for the total number of outcomes, you can make it simpler by just multiplying how many in that first event, how many outcomes in the second event. So the counting principle can be extended to even more. So when we looked at the sheets example, we had king, queen, full, twin. So 4 outcomes for the size of the sheets. We had flannel or cotton. And then we had striped, solid, or flower. So 4 times 2 is 8. 8 times 3 equals 24. So instead of having to do that whole tree diagram, we could have just said there were 24 outcomes. We were not working on the counting principle yesterday. We were working on drawing out the tree diagram so we could see the specific outcomes. Anthony?
Did you make a tree to see if you get the correct answer?
Yes, you could always make a tree to double check your work. Definitely. Will.
Does this work on every problem
for if you are trying to find how many possible outcomes? Yes.
Oh, so you just does that?
No, because then we wouldn't have learned how to do the last problems. We wouldn't be able to say how many were the evens or how many were the drawing game and the crossword puzzle. So you need to know how to do the tree diagram to answer those kind of questions. You can't answer that with this. If I say there's 24 possible outcomes, I couldn't tell you how many of them are king-size sheets with stripes, right? So you have to be careful with that. Mia? Yes, I believe so. I'll have to look at the con to see what the Khan Academy was. It should. Okay. All right, so using the counting principle to find the number of different choices at the track meet with 6 running events, 3 throwing events, and 2 relay events, use the counting principle. So we need to find the product. What does it mean if you're finding the product? Anthony? Multiply of the number of choices for each track meet. So there were 6 running events times 3 throwing events times 2 relay events. How many events are there possible? How many choices for each track event? Josie. Yep, because 2 times 3 is 6. 6 times 6 is 36. So there are 36 different choices. Another example, the standard New York State license plate has 3 letters followed by 4 digits. How many different license plates are possible if the digits and letters can be repeated?
What numbers are you allowed to use?
So, think about a license plate. What numbers are on a license plate? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many, if it says 4 digits, we know that there are 10 digits. There are 3 letters, and they can be repeated. How many letters are in the alphabet? So what is our possibility of letters? How many letter possibilities are there? Well, you gotta do the math, friends. There. Oh, how did you get that, Peyton?
26 times 3.
26 times 3, and you got 78. That's how many in our first outcome. 26 letters times that 3. Now we have 10 digits, and there's 4 spots for 10 digits. Nick?
40 combinations?
So there's 40 combinations for the numbers, for the digits. How many combinations altogether? Ryan T.
3,100.
Oh my goodness. We're going to do this a different way. Ah, I made that too simple. So there are 7 spots on the license plate, right? 3 letters and 4 digits. So how many possible choices are there for our first outcome? Because we have 78. There's 7 spots on the license plate. First, it's 3 letters. 1, 2, and 3 are our letters. So how many possibilities, outcomes for our first spot? 26. Because there's 26 letters. So there's 26 possible outcomes for number 1.
7 spots. That'd be 36.
How many letters are in the alphabet?
Oh, yeah.
Okay. So for number 2 is another letter. How many possible outcomes?
26.
Number 3 is a letter. Number 4 is a digit.
9. 10.
Yeah, don't forget about 0.
Oh, wait.
Number 5 is a digit.
10.
Number 6 is a digit. Number 7 is a
No
digit.
way.
What do I have to do with all of these numbers?
Add them up.
No, we don't add them up.
Multiply.
I knew the first way I looked at it was too easy. We have 7 different possible spots on the license plate, so we have 7 different numbers we have to multiply together.
Oh, let's go.
Anthony, what is it?
It's 1.75760.
So it's 175 million,
I got 40.
760,000. So let me see how your calculator wrote it up.
Yeah.
And there's an E on the top, meaning that there's the exponent, so you needed to multiply that. I don't know why they did it that way, but yeah. I don't know why your calculator did it that way. So it is 175,760,000. It's a lot of different license plate possibilities. Do you see how we found that? There were 7 spots on our license plate, so we needed to figure out how many outcomes for each spot. Then you multiply them together. So again, you find out how many spots there are, how many events you're doing. Okay, we did 7 different events, so we have 7 numbers we had to multiply. Does that make sense? So you always have to find how many events there will be, and then you multiply all those numbers together. So let's do one last example. Solve a multi-step problem. You are assigned a computer-generated 4-digit password to access your new voicemail account. If the digits can be repeated, what is the probability that your assigned password is 1, 2, 3, 4? So we want to use the counting principle to find the total number of different passwords. So how do we find the total number of different passwords? So I know I have 4 different events. How many possible numbers or digits in each event? 10. Well, let me double check to see if they use the 0. Yep, they did. So each one, there are 10 because we can repeat numbers. If you cannot repeat one of the numbers, then it would be 10, then 9, then 8, then 7, because you can't repeat a number that's already used. But it says we can repeat. So how much would that be? So there are 10,000 possible outcomes. Only one of them can be 1, 2, 3, 4. So how do we find the probability?
You do 4 divided by.
No.
Oh,
How do we find probability? No. How do we find the probability? No.
Oh.
What did we talk about? We did it in yesterday's assignment. We did it a lot 2 days ago in our assignment. How did we find the probability? Hurry up.
Oh, you like divide?
What do I put on the top?
Oh, the number.
1, 2, 3, 4. 1, 2, 3, 4. Resolution. 10,000. 10,000.
Total over. No,
Scarlett.
I'm not even gonna try.
Successful outcomes.
Oh.
Successful outcomes over total outcomes.
But isn't it 1 over 10,000? No, it is.
So it would be 1 successful over 10,000.
So it'd be 1 in 10,000.
1 in 10,000 probability that you're going to get 1, 2, 3, 4 for your password.
What's the percentage?
What if you can just make it 1, 2, 3, 4?
It's still a 1 in 10,000 probability because you had 9,999 other choices to choose from. So to solve this one, it says find the probability. Do not forget how to find our probability. The number of successful outcomes over how many outcomes altogether. You have to remember that. We've used it in every assignment this week. To find the probability, you put the successful outcomes over the total outcomes. So we had to find our total outcomes. Total outcomes was 10,000. Then we had to figure out that 1, 2, 3, 4. There's only one outcome. That would be 1, 2, 3, 4. And so plug it into your formula.
It's like.
It did not say that it needed it in a percentage, so I would accept it as 1 over 10,000. You could put it in a percentage, you could put it in a decimal.
So would you put
Well, it can only
1
be
in 10,000 plus 2 10,000 plus, or just multiply?
I'm sorry, what was your question, Anthony?
Would you do like 1 to 10,000 plus, like plus 2, 1,000? Okay.
Why are you plusing 2?
Or multiply.
I don't understand. These numbers, yeah, these numbers are how many events we have. There are 10 possible outcomes for event 1, 10 possible outcomes for event 2. This is my answer. That is the probability.
The decimal there's no percent.
There is no percent, you are correct. There wouldn't be a percent on
One
this
in a percent.
because our decimal would look like that. So there is no percentage that you could write for that. So you are correct. It would have to either be as a fraction or as a decimal. For this one, you wouldn't be able to do a percentage because it's so small. Okay. So our assignment is page 173 and 174. So 173, they're telling you how many outcomes there are. Event A had 12 outcomes. Event B has 9 outcomes. Using the counting principle, what do I have to do? No, I didn't say probability. So using that counting principle to find the number of events that can occur together, you would multiply.
Oh, that's it.
That's it. So down here, excuse me. Shh. For our word problems, you need to figure out how many events that you are multiplying together. Make sure you're answering the question. Okay, so look at the events and answer the question according to that counting principle with the events. On the back side, there are more word problems. So be careful when it says probability. That's when you have to do successful over total. So remember, put at the top of your page, probability equals successful over total. So you'll have to figure out how many of successful outcomes there are and what our total number is. For my friends at home, we hope you are well, and we hope to see you soon.